see, we're talking about slopes and y-intercept, but first we need to talk about what each of them mean. There's actually formulas and equations we'll be working with together, as you can see, equations. So let's start off with our first example. So we have a slope of -2/3. You might be asking yourself, hey, why is it a fraction? And y-intercept is 1. Okay, 1 is like a whole number, so how come it's not a fraction like a slope? Well, it differs in between, and I want you to note something. Let's use a different color for our definitions. Probably go say red. Red is my favorite color. But let's start off with one note here. So equation to solve this is always, if you may know, you might get your math notebook or paper or document and put y equals m. So we'll talk about which of the letters what they represent. So y equals mx plus b. So as you can see, we have y. I know it looks like an s, but I'll change it to y. The y is, it's like saying f of x, but we could just say y equals mx plus b. So the m, what's the m? The m and the b is the main important letters in slope-intercept forms. So maybe you could say m is the slope, which we have and it's already given to us in the first sentence right here. We also have the b, which is the y-intercept, and it's right there. So y, I'm going to put y-intercept. Actually, C-E-P-T if you want to maybe spell it out. There you go, y-intercept. And this is the way it's actually written. So this is if you have like a little, like a little graph with a little line. We'll talk about those later. But let's start off with the equation. We have the equation y equals mx plus b. The m is always a slope. The x is part of it, which is the x-axis of the part, and like it's like the not the line of the graph, but it's like the, if you know like how it is. But and then like the b is the y-intercept, which is how much it'll go up. So let's start with the first example. So let's write this into y equals mx, which is it's called the slope-intercept form. So if you think about it, slope-intercept is mixed together. It's like saying like slope and y-intercept, but it's called slope-intercept form. I may see that in little tests. But let's start off with writing this into equation, then we can start looking at graphs and stuff. But let's start off with this. Slope is -2/3, y-intercept is 1, and we have it straight there. What was the y? The y equals y. Now we have the -2/3, and the slope is means equals. The slope is m, and m equals -2/3 plus the y-intercept, which is 1. So m equals -2/3 plus b equals 1. Now we can put it all together. We have all our information. M equals -2/3 plus b equals 1. So you can put our y, m, which is -2/3. Like I said, the m is the slope, so -2/3 plus. Actually, we need to always add our x because it's important. So we have x plus. Now we can solve it by using our b, which is the y-intercept. So that is 1. And this is the way we write a slope-intercept form. If you think about it, you see that we have when you think about it, you see that the slope is always a fraction. What if we said -3/3? It could be a whole number, but it's commonly a fraction. For example, if we say 3/3, that's actually, we could say it's a fraction or a whole number, but it's best we use it as a fraction to represent. And so there's other equations that I want you to work with if you're finding for slope, or if there's numbers, set of numbers, but you actually don't see the graph. We'll talk about it later in this section. But let's erase everything. Maybe could use a little napkin here. Take all this away. Oh, we want to erase the rest of this. Okay, graph the equations. Okay, now we want to graph linear equations. So I'm just going to put graph linear. Accidentally erased the title. Equations. some examples. We're going to use a graph to probably represent how this is going to work. So let's start off with, we'll actually be working off with tables too. So let's see here. I am going to first start off with some positive slopes and also some negative slopes. Wait, you may be asking yourself, hey, what's the difference between a positive and a negative slope? I thought positive was only for numbers and like positive slope. But what's a positive slope? Well, let's work with them right now. I'll use two different colors, black and red. So we have our little plane. I know it's not a good plane, it needs to be equal. Just like a little cross. Just like so. And we also have, you can put numbers in, you can put lines, check marks to represent the numbers, but whatever you want. Let's start off with a positive slope. Positive slope is like this. If you think about it, we have the z-axis, which is like this. If you think about it, we have like a, which is the thing pointing out like this, if you think about it. So we have like the y, or the x, and the z, which is always a horizontal, the diagonal line, or the one that's going orthogonally like this way. Not orthogonally, but diagonally this way. So it's going to be like that. As you can see, these this is an adjacent part of the slope, and if you can think about it, you have the z. This is not too, no, my handwriting, z is not good, but we're actually talking about the positive values. If you could look at it, maybe you could put 1. So think about it. If we have 1, 2, 3, 4, 5 on the x, and like so on for 1, 2, 3, 4, 5. You see that the numbers, and you're right actually, you're thinking about numbers as, think about it with the numbers of going up and down for negative, but you see that we have 1, 2, 3, 4, 5, which is always going to the right, meaning it's going to be positive. So is the, if you think about it, it's the z, which is, it's not the same as a negative though, and if you think about it. So we're going down. I'm not making a triangle, but I'm actually making a little slope. That will become a negative, which is actually, if you think about something, the opposite. So, so 1, 2, 3, 4, 5, you can see that the digits are going up by ones, and so is the z, which is also going by the, see, this is like 2, 3, 4, 5. So we have all this. Now that you know what a positive is, let's talk about negatives. Alright, so let's first start off with some of the examples here. So this time I'm gonna make something different. Last time I was like this, so this time I'm gonna make a, what can I say? Maybe let's see how does this work. Now, if you think about it right here, let's put it on a graph. It'd be a graph, good. And positive, negative slope. Now, if you think about it, we have it, the y-axis always matters at the slope. If you look at it, anything that's going negative will be negative. It's not positive, negative, it's not like that. If everything is positive, yeah, it's all positive, but there's a negative, so we call it negative, not positive, because we can't call it negative positive. So if you think about on the graph, it's going down. If you think about it, it's going down. Like if you can see, like this is going down. It's not vertical. Horizontally, if you think about it, it's going this way. So if we're going down, this is like, let's say this is 5, 4, 3, 2, 1, right? Which is going this way. Or negative 5, negative 4, negative 3, negative 2, negative 1. Anything that's going this way is always a negative value. So we're not going this way, we're actually going this way, which will become the y-axis. So this is negative 5, 4, 3, 2, 1, and so on and so forth. So we could put it on here. Anything that's going down is going to be a negative slope whatsoever. So if we think about it here, we can put it here. If you think, as long as it's going down, it's always negative. Because if you think about it, positive is up, which will be going this way, and then negative is going this way. As you can see, it's going downwards, not going this way. So it's actually going this way. Even though you're going this way, if you think about it, it's a negative slope. So if you're going this way downwards, if you think about the y, it's negative. So you can tell the difference between them. Now we can start graphing some equations using y equals mx plus b plus the concept of the negative and positive slopes. So let's start off with some examples. I'll draw a coordinate plane on a grid, but I'd like to start off with some examples. Let's see. I'll do maybe like 5 lines, 5 tick marks. All right. So we have a little coordinate plane, but this time I'm going to make a positive and then a negative on the other side. I'm going to make some room. So let's see. 1, 2, 3, 4, 5. And if you want to draw a coordinate plane, the lines always have to be in equal spacing. You know what I mean? So equal spacing is very important because we're probably going to be like different. Like, whoa, this triangle is not the same as the other triangle. If you want to graph some transformations or free images on the graph, you can maybe try to. We'll talk about those later in the section, maybe like in a different chapter. But let's start out with this. So you don't have to number them because you already know this is negative, or you can just put like this is the negative values. I'm just going to put negative, and this is going to be positive values, and negative values is going this way. So if you think about it, let's go up. So another 5. You can't just put like 6 on the bottom, 5 on the bottom. It has to be all equal. Everything is equal in a coordinate plane. Spacing, the numbers, the number of tick marks and stuff. Just like that. It doesn't have to be like very doesn't have to be perfectly equal, but as long as they're approximately equal, it has to be like so. And let's start off with some examples. There, see? These are all equal. That way it's better. You already know that positive is going up, positive is that way, but let's just start off with a Tory thing. Alright, so here's what I'm gonna do. Oh, never mind, it's nothing. So we go up. I'm gonna draw positive slope that goes up through the line. Now, the most important thing in this is that we want to, try to measure the values. We can't just randomly put it on there because it will be something different. So, let's start off with an example. I'm going to put a positive slope right here. And the slope is all, I call the slopes a slant. As you know, like there's like if you read, you can see that we have a slope in there's a hill. Hills are slopes, and that's what they actually call them. So I would represent that as something I would. All right. Here is what I'm going to do here. Now, oops, I don't want to put this in. Let's put it on. I like to do this. There you go. And I'm going to put that little thing right here. And I'm going to, just to be like, alright, so now, our first point that crosses right here is right here, and then right here. I'm going to make a big line for each 3. Alright, now, I don't want to make a square. Alright, so now, we have everything. Now let's take a look at what we're going to do. Alright, we have a slope. And maybe I kind of want to make it clear in the way that I'll do that. Alright, so we have the positive slope, and I may want to drop some arrows. There you go. Alright, so we have a slope on the graph. Now, if you want to find a slope on a graph, it differs from finding a slope using, what's it called? So they're called instead of it's like a set of points. For example, if I had like 0, 3, they call them instead of not quadrant, I don't know, but it's actually shape. We'll talk about that more in the sections and everything we're going to talk about in the sections. So again, let's start off with an example. We have many more. So let's instead of I'll think about it later while I'm teaching, but lecturing. But let's talk about the positive slope. We have these right here, as you can see. So we have -2, which is going here. So this is when we find the slope, we want to get from the very bottom point, the lowest or the highest point on the y-intercept. Anything that's on the y is always going to be the y-intercept on the y-axis, which is always like it's always going to be the set of ordered pairs actually. So it's called ordered pairs. The set of ordered pairs would always be the x would be always equal to 0. So we could put 0, and then we could put the -2, which is going to be the y-intercept, or we could put 0 is 2b. But that's just to represent. It's just to represent that. So start off with the -2. So we have -2, which is going to be the y-intercept, but we want to get on from there to end up at 0. So if we go up to 0, we would say, okay, so we could go up 2, which is going to be the b equals going to equal 2 to get from 0. Now all we need to do is use rise over run. And this is a very, I like to use this formula because it helps me when I'm graphing. So the rise over 1 should, so if you go from 0 and get to this point at the ordered pair of 3, 2, we want to, 3, 2, we want to start off with figuring out how to use in terms of rise over run. So we have to start at 0. To get up, we need to go up 2, which stops at that point right there. So 1, 2, which is a rise of 2, a run, horizontal, whether it's horizontal or vertical, horizontal or positive or negative, it's a run. But the sign would change. It's the only thing. So we go this way, so we count 1, 2, 3, and our point is right there. I mean, solve the slope. All we need to use is using it to slope-intercept form in a fraction. So I would say, let's see, rise over run. So there's no negative values, and therefore n equals 2 over 3. We don't need to figure out y, because y is the y. It's original and x, right? So now, you know that we have all the examples. Now all we need to do is write the equation into y, the slope-intercept form. So the y is just y. We need to replace anything. So y equals 2 over 3, but we have the x also plus, what was the y-intercept? We went up to figure it out if you forgot. Just go up to the origin, 1, 2, which is going to be 2. So you have your slope-intercept form. This is the m, this is the x. If you think about it, you're replacing, you're just plugging the values of m and b. So, that's the way to solve it. Now, we'll talk about graphing more equations, but there is a special one I like to show you. There's a special, this time, it's not what you think it is. We are writing it in slope-intercept form. However, I'd like to show you something. Now, let's say I had I'm making negative slope, so we have a little plane right here. It's just like so. I want to make it equal, just like this. There you go. Actually, it's kind of soft. The sides are kind of too big there. That's kind of equilateral right there. Actually, there, right there. Now, this is easy to look at. So, let's see. I'm gonna put maybe 3 of these, or actually 5. The weight was 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's outside. Sorry about that. 1, 2, 3, 4, 5. All right, now we can start graphing our negative slope, which is going to be, remember, it's this way. Think about it, the z-axis is going to go this way, but it's going to become a negative thing. So let's start off with the negative slope. If you think about it, we can start off with a little example. This is going to be a little hard to draw. So the origin is right here, and I want to draw a little something right here. So I want to draw a negative slope that goes from here to there. All right, I got it. So there's going to be the slope of the line passing through the origin. So the origin is going to be right here, and then this is going to be the next point. All right, so this is not what you think it is. We're not putting this in this time. I want to show you something different. All right, here's our negative slope. If you look at the negative slope of the line, you see that we have many of these examples in the. It's the same example, but we are still using y and x. But there's something which we're not actually using. So, well, let's see what that is. All right, so the y-intercept. Where is the y-intercept? It's already at 0. So it's 1, 2, 3, 4, there's nothing to get up to the origin because it's already at the origin, so I'm going to put b equals 0. What about the slope? The slope is kind of close to the origin, but not the origin. So the rise over run, remember that? The rise over the run. Now let's use that. The rise to get to the other point would go up 1 over, we're at the point -1 since we go to the left. So the m equals, we just put 1 over 1, -1x. Or we could just put the leave it like that. And if you think about it, 1 over 1 is just 1. And if we say 1x, because -1 over 1 is a whole number of 1, and therefore we need x too, like we have -1x. We don't say 1x, we just say x because it's 1x. 1 is not, like 1 times 1 is 1 and it doesn't change anything. So we just say it's x. Now, here's how I'm going to write it. Here's the actual way to write it. Y equals, the answer is y equals -x. Whoa, wait, what happened to the n? What happened to the b? Isn't there supposed to be a b? Well, here's the thing. The y-intercept is 0, meaning there's nothing. So if we could just, it doesn't make sense to say y equals -1 over 1x plus 0. Well, there's nothing there to say that the y-intercept is 0. So because 0 is zilch, it's nada. There's nothing, right? So we just say, hey, this crosses out. The 1 over 1 is just 1. But when we say 1x, it's just x because 1x is just 1 times x is 1x. I know, yeah, 1 times x is 1x, but we just say x because that's the way to say it. We just take away this 1. 1 over 1 is 1. 1x is equals x. So that's why we say, if you think about it, you see that was -x. So that's how we just erase it and just say y equals -x. That's the slope of the in y-intercept form. So it's kind of like a tricky one. Was it just as you thought? So this is the way we write it in slope-intercept form. We could use tables. We could use even some more like, we could even use graphs and tables and charts and word problems, right? Now, this is one of the formulas that are here. Rise, oh, sorry about that. I'm gonna use my napkin to erase everything now, so now you understand how we can just y equals -x. So let's just start off with another example. One more example using a table. Hey, what happened to the graph? How do we solve for tables in slope-intercept form? How do we do that? Well, here's our next formula. Now, here's going to be my table. I'm going to make a, let's see, think about it. I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9. Maybe like 9 rows and 2 columns. And that's how I think normal is. It's always going to be 2 columns. But you can make as many rows as you want. So now let's start off with making up a bigger one. Now let's start with making a table. Sorry about that, it's a bigger one. So just know by these kids, but again, let's just start off with an example from a table. Alright, so we have our first row. Now let's make 1. So we've got 1 square, 2 squares, 3 squares, 4 squares, 5 squares, 6 squares, 7 squares, 8 squares, 9 squares. Alright, we got all of them. Alright, that's funny, I know, that's kind of funny. But, let's hear. Alright, I made my horizontal line, which I'm going to make actually right now to connect them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hey, I don't want this row, so I'm just going to take this away. Let's take this, take this, take this, take this, take this. There you go. I think this is going to be final here. Okay. Alright. So let's take a look at some examples. If you look at the I'm gonna put y. I'm gonna make it smaller font so I don't actually get out of the line. So let's start with this. So I'm gonna put the y and the x. The x is gonna be at the bottom. I'm choosing to put it there. So y, this is going to be y right here, and this is going to be x. So we have, all right, so here's the thing. I'm going to start with negatives. -6, -3, 0, 3, 6, 9, and then we could put 12. Or I could say 9, 6, 3. Maybe I could add negatives. Watch, here's what I'm going to do. -, -, 0, 3, 6, 9. There we go. Now our x's are going to be the opposite. Now we're going up now, so this is going to be -2, 0, 2, 4, 6, 8, 10, and we end up with 12, but actually positive. So here's the form. Here's the thing. All right, I'm going to start off with an example. All right. So the positive values. Now, here's our second formula for the day. Now, the slope equals, I'll be done after this, which is going to be the last one. Happy now? Well, education is very fun. Slope equals the change in y over the change in x. This also could mean triangle, but it's this sign, this triangle, it means delta. Or it means a change in something. It's a rate and change. So if you look at the rate of change in the table, rate of change meaning it's constant. It's constant. You know, the pattern of the numbers are going constant. So this rate of change. If you look at it from 9, 6, 3, 0, if you see a pattern, it's going negative. It's -3, -3, -3 from here to here, here to here, and here to here. It's going by negatives. But if you look at it here, it's going to go by positive 2's. And so the change in s is actually going by, it's going by 2's, 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 and so on. So I would just go here, 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 and so on and so forth, right? So I'm going to put plus signs to represent that these are positive values, not negative, because the pattern is actually going by 2's. So -3 over 2 is an example of the slope of a line, and we already found it. But how do we find the y-intercept in the table? Well, here's what's going to happen. When you want to find a y-intercept in a table, the x is 0. So y-intercept means x is 0. So if you look at it here, the y-intercept is actually 6. Not 4, because why is it not y-intercept should be 0? Because the x is going to be 0 and the y is going to be the 6, the actual number. So y will get the result, but we need x0 to represent that, so we could just have y only, right? So we can put y equals -3 over 2 x plus 6. And that's it. We solved, or we put all this in a y-intercept form. The x is 0 because we need the y value. The y value is 6. If we had 0 here, then the y-intercept would be 3, and so on. And that's how a slope-intercept form works. We'll talk about, actually, there's one more formula if you want to work with ordered pairs and find a slope with ordered pairs. We'll talk about that maybe later in a higher level. I'm in a higher level, but maybe like a different chapter or a different section or a different course. But we'll talk about that maybe you'll actually learn about it probably in different courses or this e-course. But again, thank you so much for my video, and I hope I'll see you in the next section, 1.2.